So the next group of problems is written in what I called standard form. They have a parentheses with a square outside of it, and that kind of makes it standard form when there's like an x plus a number or x minus number inside the parentheses. And for each one of these types of problems, we're just going to take the number that's in the parentheses and change its sign. If it's negative, we'll put a positive version of that in the middle of the table. If it's positive, we'll put a negative version of that in the table. And your 7 and my 8 will solve similarly. Both of our problems have an implied 1 in front of the parentheses. If there's a positive number in front of the parentheses, it's a right side up parabola and we'll get a minimum point. If there's a negative number in front of the parentheses when it's written in standard form, we'll get an upside down parabola. So if I was doing problem 8, immediately I recognize this to be in standard form. A parentheses with either a plus or a minus sign. Standard form technically has a minus, but I can live with a plus just fine for our purposes. So I'm going to take the number inside the parentheses and change its sign. Go bigger, and then go smaller. For each x, I need a y. Just for the first problem, I'll emphasize what I'm going to enter on my calculator. But ultimately, I shouldn't be writing this down. This is almost just silly to write down. But these are the 5 values I'm going to enter on my calculator. Realistically, once we get a little deeper into this, I might revert to just doing 3 values. If I have the vertex and the value above and below the vertex, that's probably enough. So my first y value is 10, and then I'm just using the feature on my calculator to allow me to quickly change a number. It's kind of mouse key for lack of a better word. If you get duplications, meaning your top and bottom y's are the same, you're in a good place. If like on that first problem that I was graphing, my top y didn't equal my bottom y, well then I have got a mistake. It's either a mistake in creating the table or it's a mistake on my calculator. So let me plot these points. So 0, 10, I don't know why my graph goes so high, but it does. 1, 7, 2, 6. I always make the vertex in the middle of my x column, so that's usually the only point I take the time to draw. 2, 6, and then 3, 7, and then 4, 10. It has to happen when you set the tables up like I do that the y's duplicate. If your y's don't duplicate, you don't have a good table or you've made a math error. It's proper to sneak little arrows at the end of my graph saying they go on forever. So now I've made my table, sketched a graph. Let me identify everything I need to. The vertex is the point 2, 6. This vertex, because it's at the bottom of the parabola, it's a minimum point. If the number in front of the parentheses is positive, the vertex is a minimum point. If the number in front of the parentheses is negative, the vertex is a maximum point. And then I'm going to make my comment about the y value of the vertex. The y value of the vertex, y equal to 6, is the lowest y value of all the points. And it occurs when x equal to 2. This comment always uses both the x and the y coordinate of the vertex. I didn't draw my axis of symmetry in. Not so hard to draw it in. There's my axis of symmetry. An axis of symmetry always has the equation x equal the x coordinate of the vertex. So this axis of symmetry has an equation of x equal to 2. So you should be able to do number 7 just fine. Let's do an ugly one. Let's do your number 11. It's ugly, but with a calculator, not so bad if I'm willing to graph some decimals or fractions if I need to. So this is still standard form. It's a number times a parentheses with an exponent of 2. That's the minimum part of it. Could have something added or subtracted after the fact. That's not necessary, but it's nice to have. So my table for number 11. I take the 4 that's in the parentheses and I change its sign. And then I go smaller and bigger, and it doesn't matter when you're incrementing by 1 which direction you're going. Now I'm going to use my calculator and get my y's. I almost think it's easier for me to graph decimals. So if I get a ugly y coordinate, I might just make it into a, I'm afraid to do that actually. I think I'm just going to leave it a fraction, specifically because I don't want to lose this whole line right here. I want to be able to use this line over and over again. Let me just see what happens. Oh, that one's not a problem. Let me change the -6 to -5. And I get, -11/2. Let me put this off to the side. I don't need to graph all 5 points. Let me SD it. Oh, -5.5. I can do it without losing. I was just afraid when I hit the SD button, I was going to lose the ability to do this. And I didn't want to lose that ability. But nevertheless, I don't need to plot all 5 points. I need the vertex, and on 1 point on either side of the vertex is the minimum that I need to graph. I'm going to find all 5 points just so I could see that symmetry. If I have any mistake, it's going to show up in the creation of my table, because I'm not going to get the matching duplicate y's like I did here. So this is adequate enough. I'm just going to graph that point, and that point. I have no need to graph the decimals. I could graph them, but they're not necessary. So -6, -4, -4, -6, which is the vertex, and -2, -4. The other points are down in here, like -3, -5.5, -5, -5.5 are there. You can graph them, they're not that hard to graph, I guess. Putting a fraction in front of the equation makes it really wide. My vertex is -4, -6. Let me draw in my axis of symmetry. It was a right side up parabola because the number in front of the parentheses is positive. So let me answer everything. The vertex is the point -4, -6. The vertex is a minimum point. The minimum y value is y equal to -6, the y coordinate of the vertex, which occurs when x equal to -4, and then the axis of symmetry always has the equation x equal the x coordinate of the vertex. So there isn't really a lot going on in this section. It's really getting the x's in the table, because my calculator would help me with the y's, and if I see a graph, answering the questions aren't that bad. It's obvious if the vertex is a maximum or a minimum point based on where it's located. This verbiage we've had before. The axis of symmetry is new, but it's just x equal the x coordinate of the vertex. I want to do an upside down one, but let me find one that's, well, let's do one in standard form together, and then an upside down one in standard form. So, or general form, should I say. So this equation is in this general form. It has both an x squared and an x. So the first video, I did problems that had just a single x squared without a parentheses. I used -2, -1, 0, 1, and 2. The first few problems in this video, they were written in standard form. I changed the sign and shoved that number in the middle of the x column. That's when I get a parentheses. If I don't have a parentheses, I either have one x squared term and no x term, or both an x squared and an x term. If I have just an x squared term and not an x term, I use the -2, -1, 0, 1, 2 table. If I have both an x squared and an x, which is going to happen in the problem we're about to do, to get the number in the middle of my x column, I kind of use the part of the quadratic formula without the square root. So to get started on number 15, I need to know what a is, which is the number in front of the x squared term. I need to know what b is, which is the constant, and the number for the middle of my x column is gotten by the formula. I just can't inspect to get the number for the middle of the x column in my table. I need to use the -b over 2a part of the quadratic formula without the square root. -b is going to be -6. 2a is going to be 2 times 1. This is going to be -6 over 2, which is -3. So when I go to do my table, I'm going to put -3 in the middle of my x column, and I'm going to go increment by 1 in both directions. And then for each x I need to get a y. The proper way to write it would be like this: f of -5 equals to the quantity -5 squared plus 6 times -5 plus 5. That's the proper verbiage to write there, but I'm not going to. I'm just going to do these on my calculator. So first y, -5 squared plus 6 times -5 plus 5 gives me 0. Now change both -5s to -4s for the second point in my table. Without writing all this down, it's not necessary unless you just feel the urge to write that. And then make my -4s into -3s, making sure you make both of them -3s. The mistakes will pop right out at you. If you have a mistake, the y's won't duplicate. The top y's and the bottom y's, second from the top, second from the bottom, they need to match up. And I have no desire to do tables by hand. So that's perfect. I see the duplication that I want. Let me plot my points. So -5, comma 0, -4, comma -3. The only value I generally plug in is the vertex, and this is -3, -4. That's my vertex. It's a minimum point because the number in front of the x squared is positive. Turns out negatives in front of parentheses, negatives in front of squares make it a maximum point. -2, -3, -1, 0 make my u more than a u than a v. A lot of times I see v's as opposed to u's. I don't take points off for that. I can never take points off for art issues. Drew in my axis of symmetry, I'll even write the equation down because I know the axis of symmetry only has an x because it's a vertical line, and it's going to be x equal the x coordinate of the vertex. Let me answer now the parts I need to make comments to. So the vertex is the point -3, -4. This vertex is at the bottom of my parabola, so the vertex is a minimum point. It's hard to tell with negatives, but the y value of the vertex is smaller than the rest of the y values. The minimum y value is y equal to negative 4, which occurs when x equal to negative 3 The only hard part really is knowing what to shove in the x columns, because the rest of it is all repetitive. It's just looking at the graph and figuring out what I need to figure out. Let's find an upside down parabola. Number 20 is an upside down parabola, so I'm going to pull it out. I'm not going to do so many more problems. We're at 16 minutes. This will probably take me 4 or 5 minutes, and I feel like that might be adequate. It's just knowing what table. If you have a parentheses, you change the sign of the number in the parentheses, shove it in the middle of the x column. If you have no parentheses, but only an x squared and not an x, you use negative 2, negative 1, 0, 1, 2. If you have no parentheses and you have both an x squared and an x term, you use the negative b over 2a problem. This was on the first video. These were on the first part of this video, and this is what we're doing now. This is written in general form because there's both an x squared and an x. It's going to be upside down. The vertex is going to be a maximum point when you get negatives in front of the square term. So I need the number for the middle of my x column. The y's must get really large based on the numbers I threw on the y-axis. I'm sure I graphed these ahead of time and found an appropriate window. I'm going to use the formula negative b over 2a, where a is negative 2 and b is 24. This is the only kind of problem for graphing parabolas that I can't just inspect and know what the vertex is. If there's not a parentheses and there's both an x squared and an x term, you need to use this formula. So negative b in the numerator becomes negative 24. 2a in the denominator becomes 2 times negative 2. I get negative 24 over negative 4. I'm going to put a positive 6 in the middle of my x column and then go bigger and smaller. See, I get lazy. I don't often label the table properly. It would maybe be to do x and h of x because the function is named h of x, but y is also fine. Similarly, my program just calls the y-axis y, and I'm happy with that, but you might see somebody change the name of the y-axis. Let me do each of my x's now. Y, should I say. My first y, I'm going to go negative 2 times 4 squared plus 24 times 4 minus 40. So negative by the fraction 2 parentheses 4 squared plus 24 parentheses 4 minus 40. It's going to give me 24. And now I'm just going to backtrack, change the 4's to 5's, and get 30. And then change the 5 to 6's. If I was confident, I would stop now and just write 30 and 24 down. But I make so many mistakes, I don't have that confidence. But it should happen that this one, when I hit equals, I should get 30. And when I do the next one with the 8, I should get 24. My y's have to repeat. I always stick the vertex in the middle the way I construct my tables. Beautiful. These points I'm just going to have to wave my hands and kind of approximate the plotting because it's not going to be that good. 4 and 24, and maybe it's about there. This is an upside down maximum vertex. 5 and 30 I can actually get exactly. My calculator, my program gave me that. 6 and 32, another kind of just guesstimate where it's at. 7 and 30 I can do accurately. And 8 and 24, again, is just kind of an approximation. You're going to increment your axes if you're, by hand, by, at least 5. Mine are incremented by 10s. when the units on the y-axis are far apart and the units on the x-axis are close, it distorts how the parabola looks. It makes this look wider than it really would. If I was able to increment both axes by 1, it would look different. It would look narrower. So it kind of distorts the perspective. It doesn't matter that it does that. I have to live with it. Otherwise, I just can't fit the graph on a easy. I need a huge sheet of paper to graph it, incrementing the axes by 1. So vertex 632. Vertex is a maximum point. Let me get lazy now. Vertex max point, rather than writing something that's more sentence. And lazy again. Max y value. Y equal to 32 when x equal to 6. This is how we start to get lazy. Instead of writing whole sentences, or writing something that kind of approximates the sentence. And then axis of symmetry, which I need to draw in. X equal to 6. Let me draw it in. This is my axis of symmetry. And the axis of symmetry always has the equation x equals the x coordinate of the vertex. Let's just not do a higher problem, but let's talk about the table that you would do if you were doing 21, and the table that you would do if you were doing 19. So without graphing, if you can get the tables, that's all, everything's freebie. So in both 19 and 21, because they both have an x squared and an x term, to get my table started, I have to use the negative b over 2a formula. So if you were graphing number 21, a is going to be negative 1, b is going to be negative 6. You'd go negative from the formula, and then negative 6 for the b, over 2 times, that's supposed to say 2 times a, 2 times negative 1. That's going to be positive 6 over negative 2, which is going to be negative 3. So when you're doing problem 21, you'd put negative 3 in the middle of the x column, and then increment up and down, and it doesn't matter the order that you increment, the y's are going to be the same anyways. So that's the table I would use for problem 21, negative 5, negative 4, negative 3, negative 2, negative 1. The vertex is going to be negative 3 comma something. It's going to be upside down. The vertex is going to be a maximum point because of that negative. And number 19, the vertex is going to be a minimum point because of the positive in front of the squared. And it's also in this grouping that has both an x squared and an x to the first power term. So I need to use the negative b over 2a formula to get the number in the middle of my x column. The other problems, I can get the number for the middle of the x column by inspection. There's no algebra to do. For this problem, though, because it has both an x squared and an x, I need to do this bit of algebra to get my table started. So in problem 19, I'd have a negative 2 in the middle of my x column. And the vertex is going to be a minimum point. It's going to be a right side up parabola. And doesn't matter the order that I jam the 5 numbers in, but that would be adequate. So we have one section left for the chapter. It's a lovely short chapter. It's word problems, and we're going to solve the word problems by graphing as opposed to using algebra, because that's a competency for our class. So I will teach you how to solve a word problem by graphing, and it shouldn't be that bad of a section, and I don't think it's that long.